multiply. Okay, I've just been telling you to do it. So today we're going to point out why we cross multiply. So again, these first three problems are just using the cross multiplication technique to get an easier equation. This is why we can cross multiply. The common multiple of 3 and 4 is 12. So if we multiply both sides by 12, and we do the cross canceling, notice what happens. 12 divided by 4 is 3. 12 divided by 3 is 4. So we get the equation for x equals 5 times 3. Notice that's cross multiplying. So this is what humans do. They were actually solving these problems by multiplying both sides by a common multiple so they could cross cancel the denominators. And after getting this enough times, they noticed a pattern. Oh, wait, that's 4 times x, the diagonals, and that's 3 times 5. Oh, so let's just go ahead and cross multiply from now on and save ourselves that step. Okay, this is why you get an equation. Now, I know sometimes people react to what they see, so they want to put these two things over each other because they're seeing fractions. But remember, we're solving an equation. If we're going to cross multiply, we want to do that to help us solve an easier equation. All right, and so then we get this, and then you divide both sides by 4. All right. Right, so then if you want to write this as a mixed numeral, the closest multiple of 4 is 12, and then we got 3 left over. So 3 wholes and 3 left over. Denominator is still going to be 4. All right, the same thing here. Now this time you could do the same thing if you understand how to multiply both sides by the common multiple, which would be 15, or just go ahead and cross multiply. You should get the same result. Okay, and then you finish that. And I'm not going to finish that for you, but let me tell you what you should get. You should get x equals 3 over 7. Don't forget your distributive property. Sometimes we forget to multiply the 3 to the 1. All right, I can do that too. All right, let me just make sure is there any questions on that? All right, now the last problem, there's a little glare up here. That's why I drew that line there so that I remember that I can't go above that. So again, the same thing. Now we could also do the same technique, multiply by the common multiple of 3 and 4. Right, this will become 12 divided by 4, which is 3. This will become 12 divided by 3, which is 4. Right? So that's why we just cross multiply, because it's going to be the same thing. Okay, so then you solve this. Right, and don't forget your distributive property. So 3 times 5, 3 times 1. And then 4 times 2, 4 minus x. Right? And then you add your 4x, so this becomes 19x. And then you subtract your 3, so that becomes 8 minus 3. Okay? And then I'll just tell you what you should get. So you should get x equals 5 over 19. Okay, so we just finished the third of the warm-up problem. That's where we're at. We're going to get to the last problem in a minute. I just want to pause just to make sure if there's anything anybody wants to ask. Again, you could also send me a chat if that's preferable. It's okay. Thank you for letting me know. I understand. I appreciate when you let me know. Okay, so we're going to get to the last problem. which is not overly complicated, but it is a little different because you have variables on the denominator. Okay? And so depending on how you think, with me, I'd probably just get a common denominator since 3x and x are not too close or far apart from a common factor of 3, right? So just multiply this by 3 and you get 3x. To me, that seems to be the easier way. So getting a common denominator. Okay, so notice this is why we learn how to do that, because if there are no numbers there, it's the technique of getting a common denominator that we got to do. And remember, you got to multiply both top and bottom, because if you change the bottom, the value is now different. So you want to do the same operation to top and bottom. So this fraction is still the same value, right? It's just not simplified, but it's still the same value, right? That's no different than 8 over 4 equals 2 over 1 equals 16 over 8. All of those are the same value. They just have a different denominator. If you multiply this top and bottom by 4, you get 8 over 4. If you multiply this top and bottom by 8, you get 16 over 8. Okay, so again, it's important to realize that, because then we'll do silly things. We'll forget to multiply the top. Okay, or, you know, again, that's just why fractions are important, because that's kind of how we solve this problem. Okay, so now we have the common denominator. So 9 over 2, 11 over 3x. Now again, you do not add the denominators. All of us know that a half plus a half is the whole, right? If you add the denominators, that's not a whole. Again, the denominators are representing a unit. It's just representing the size of the unit. So when you convert to a denominator, you're converting to the same size units. So we have 1 unit based on a half and another unit based on a half, right? So that's why you don't add the denominators. Again, just pointing that out. Hopefully that's not really an issue, but okay, so we are almost finished with the 4th homework problem. I appreciate that person who just joined. Let's try to get here a little earlier because you're missing out. I don't know if you watched the lesson vids, but there will be one. I'll get a little later. So now we can cross multiply. All right. So now 2 times 3x equals 11 times 1. Now we can divide. Now again, it's not always divide by the bigger or smaller number. Look on the side where the variable is. We want this to become 1x. Since it's multiplied by 6, the reverse would be divide by 6. Okay, and I'm just using the line to represent division. So this becomes x, and that's what x equals. All right, and then again, to convert to a mixed numeral, the closest multiple of 6 to 11 is 6, and then you got 5 left over. So we got 1 whole and 5 left over. So 1 and 5 pieces based upon units of 1/6. All right,